In the summer of 1944, somewhere in the tangled hell of Normandy's hedgerows, a truck driver from Tennessee welded scrap metal onto the front of a Sherman tank. Within 6 weeks, that improvisation would save tens of thousands of American lives and break open the Western Front of World War II. His name was Curtis Cullin, and almost no one remembers him. The morning of July 3, 1944, dawned gray and humid over the Norman countryside, the air thick with cordite and the smell of turned earth. For 27 days since the D-Day landings, the American First Army had been locked in a grinding, brutal stalemate barely 8 miles inland from Omaha Beach. The grand sweep of Allied strategy, the rapid breakout, the race across France, the liberation of Paris, all of it had collided with something the planners had not fully understood: the bocage. The Norman hedgerows were not hedges in any recognizable sense. They were living fortifications, ancient barriers that had stood for centuries, some dating back to Roman times. Each field was enclosed by earthen berms 4 to 6 feet high, their sides reinforced by gnarled roots as thick as a man's arm, their tops crowned with hawthorn, oak, and bramble so dense that even sunlight struggled to penetrate. The berms themselves were not simple mounds of dirt but compressed layers of soil and stone, hardened over generations into something closer to natural concrete. Between these walls lay small, irregular fields, rarely more than 200 yards across, creating a landscape that resembled a vast, three-dimensional maze. For the Germans, the bocage was a gift from God. Every hedgerow became a ready-made trench line. Every field became a killing zone with only 2 or 3 narrow gates for entry. A single machine gun crew positioned at the base of a hedgerow could command an entire field, their position almost invisible from more than 50 feet away. German doctrine, honed through years of defensive warfare on the Eastern Front, exploited this terrain with ruthless efficiency. They placed their positions not at the obvious choke points but slightly offset, creating interlocking fields of fire that caught attacking forces from unexpected angles. Mortars were pre-registered on the gates between fields. Panzerfaust teams, often just 2 men with the portable anti-tank weapons, would wait in spider holes dug into the base of the berms, invisible until the moment they fired. For the Americans, the bocage became a landscape of incremental death. Infantry attacks that worked in open terrain became suicide missions. Artillery, the great equalizer of modern war, lost much of its effectiveness. Shells that would have devastated troops in the open burst harmlessly in the thick canopy or were absorbed by the earthen berms. Air superiority, which had been a decisive advantage on D-Day, meant little when pilots could not see through the vegetation to identify targets. Radio communication, already difficult with the equipment of 1944, became nearly impossible as the earthworks blocked signals. Units became isolated, disoriented, unable to coordinate. But the greatest problem was the tanks. The M4 Sherman medium tank, the armored workhorse of the American Army, was a solid machine on open ground. Its 75mm gun could handle most German armor at reasonable ranges. Its mechanical reliability was excellent. Its crew comfort and ease of production made it the logical choice for the Allied war effort. But the Sherman had never been designed for the bocage, and in the Norman hedgerows it was dying. The physics were brutal and simple. To cross a hedgerow, a Sherman had to climb. The tank would approach a berm, nose up, and attempt to crest the obstacle. As the front of the tank rose, the belly armor, the thinnest part of any tank, was exposed. For a critical moment, sometimes as long as 10 or 15 seconds, the Sherman was blind, its gun pointing uselessly at the sky, its most vulnerable surface presented to anyone waiting on the other side. German Panzerfaust teams learned to wait for exactly this moment. The shaped charge warhead of a Panzerfaust, designed to punch through armor by focusing explosive force into a superheated jet of metal, could penetrate the Sherman's belly armor with ease. The result was usually catastrophic. The round would punch through into the ammunition storage or fuel tanks, and the Sherman would brew up, the grim slang tankers used for the sudden explosive fire that gave crews, if they were lucky, perhaps 30 seconds to escape. Even if a Sherman made it over a hedgerow without being hit, the problem continued. Once over the berm, the tank's weight would cause it to crash down nose first into the next field. A jarring impact that could damage the suspension, injure the crew, and, crucially, left the tank momentarily unable to traverse its gun or maneuver. For another several seconds, it was a sitting target. German defenders, positioned at the far end of the field or in adjacent hedgerows, had ample time to engage with Panzerfausts, Panzerschrecks, or even the lighter but still deadly Panzerwerthmann magnetic anti-tank mines. The casualty statistics were appalling. In some tank battalions, crew losses approached 50% within 2 weeks of entering the Bocage. Replacement tanks arrived at forward depots and were knocked out within days, sometimes hours. The psychological toll was equally devastating. Tank crews, who had trained to think of their vehicles as mobile fortresses, now climbed into them each morning knowing that any field crossing might be their last. Some crews began to refuse orders to advance, a problem that had never existed in more open terrain. Others took extraordinary risks, charging hedgerows at high speed in the hope of getting through the vulnerable moment faster, a tactic that usually resulted in track damage, leaving them immobilized and even more exposed. The U.S. Army tried solutions. Engineers experimented with placing explosive charges at the base of hedgerows, trying to blast gaps wide enough for tanks to pass through at ground level. The results were mixed at best. The charges either failed to cut through the root systems or created craters that tanks could not cross. Bulldozer blades were welded onto some Shermans, creating improvised engineer tanks that could theoretically push through the berms. But the blades were heavy, reducing the tank's already limited speed, and the bulldozing process was slow, noisy, and attracted immediate enemy fire. Bangalore torpedoes, long tubes of explosives designed for breaching wire obstacles, were tried. They worked occasionally but required infantry to get dangerously close to the hedgerows to emplace them, and the resulting gaps were often too narrow or irregular for tanks to exploit. By early July, the situation had crystallized into a grim operational reality. The American Army was winning, in the sense that it held the ground it had taken and continued to inflict casualties on the Germans. But it was winning at an unsustainable pace, measured in yards per day rather than miles, and at a cost in blood and material that no one had anticipated. The Bocage, it seemed, simply could not be overcome by armor. The tanks that were supposed to provide mobile firepower and protection had become expensive, slow-moving coffins. Then, on a warm afternoon in mid-July, Sergeant Curtis G. Cullin of the 102nd Cavalry Reconnaissance Squadron had an idea. Cullin was not an obvious candidate for military innovation. He was 29 years old, a lanky, quiet man from Cranesville, Tennessee, who had worked as a truck driver before the war. He had no engineering degree, no formal technical training beyond what the Army had given him. He was a tanker, a crew member on an M5 Stuart light tank, and like every other tanker in Normandy, he had watched Shermans die in the hedgerows and wondered if there was a better way. The reconnaissance squadron had been rotating back from the front for maintenance, and Cullin found himself near Omaha Beach with a few hours of unscheduled time. He walked the beach, which by mid-July had been transformed into a vast logistics depot. The initial chaos of the landings had given way to organized industry. Supplies stacked in enormous pyramids, vehicles lined up in rows stretching for miles, engineering equipment working constantly to improve the roads and clear obstacles. It was the obstacles that caught Cullin's attention. The Germans had studded the beaches with anti-invasion defenses, thousands upon thousands of steel and concrete structures designed to rip the bottoms out of landing craft or stop tanks in the surf. Many of these had been pushed aside by engineers in the days after D-Day, dragged to the edges of the beach and left in piles. One type in particular interested Cullin: the Czech hedgehogs. The Czech hedgehog was a simple but effective obstacle, made from 3 pieces of heavy steel rail or I-beam welded together in the center to form a 6-pointed star. Each piece of steel weighed 60 to 80 pounds, and the finished obstacle, standing about 3 feet tall, was heavy enough that it would not move easily but light enough that it could be mass-produced and transported. Arrayed in rows on a beach, hedgehogs would tear open the hulls of landing craft. Planted in fields, they would block vehicles. The Germans had manufactured them by the thousands. Cullin stood looking at a pile of hedgehogs, his mind working through a problem. The fundamental issue with the hedgerows, as he understood it, was that tanks tried to go over them. What if, instead, a tank could go through them? Not by bulldozing, which was slow and required enormous force, but by cutting. The roots were the real barrier. The earthen berm itself would collapse if the roots were severed. What if a tank could carry a set of heavy steel blades, positioned low at the front, that would dig into the berm as the tank advanced and slice through the root mat like a farmer's plow through soil. He pulled one of the steel rails from a hedgehog, hefting its weight, testing its rigidity. It was solid, heavy-gauge steel, far stronger than anything the Bocage could resist. And there were thousands of them, scrap metal now that the invasion was over, waiting to be repurposed or shipped away. Cullin was not the first tanker to have ideas about the hedgerow problem, and he knew it. Ideas were cheap. What mattered was whether something actually worked. He found a welder, a corporal from an engineering battalion who was working on vehicle repairs nearby. He explained what he wanted to do. Cut several lengths of steel rail, weld them onto the front of a tank at a 45-degree angle, pointing downward like the prongs of a fork. The welder shrugged. He had seen stranger requests, and asked when Cullin wanted it done. Today, Cullin said, "Now, if possible, I need to test it before we go back up." They found a Sherman in the maintenance area, a battle-scarred M4A1 with a replaced road wheel and fresh paint where shrapnel had been patched. The welder cut 4 pieces of steel rail, each about 6 feet long, and welded them to the front glassy plate of the tank, 2 on each side of the center, angled down at roughly 45 degrees so that the tips would bite into the ground about 3 feet ahead of the tank's tracks. The welds were crude, functional rather than pretty, reinforced with cross-bracing to distribute the load. The entire assembly, which Cullin would later call a cutter, weighed perhaps 500 pounds and looked like something a farmer might have improvised for clearing stumps. The question was whether it would work. Cullin convinced his crew and the Sherman crew to take the modified tank to a nearby section of Bocage that had been cleared of Germans but still had intact hedgerows. It was late afternoon, the sun slanting through the trees, when they lined up the Sherman facing a typical hedgerow berm, about 5 feet high, dense with vegetation, the kind of obstacle that would normally require a Sherman to nose up and expose its belly. Cullin gave the order. The Sherman's driver revved the engine, engaged the transmission, and drove forward at a walking pace. The steel prongs hit the base of the berm and dug in. There was a moment of resistance, the tank's engine laboring, and then the steel cut through the root mat with a sound like tearing fabric. The tank kept moving forward, its nose staying level, the prongs slicing downward through the berm as if through butter. Dirt and roots sprayed up around the tank's hull. The hedgerow, which had stood for centuries, came apart in seconds. The Sherman pushed through, emerging on the other side without having exposed its belly armor, without the violent nose-up climb, without the vulnerable moment of blindness. They tried it again on another hedgerow. Same result. The steel prongs punched through the root system, the tank drove through the collapsing berm at ground level, and within 30 seconds they were on the other side. The crew was silent for a moment, processing what they had just seen. Then someone started laughing, the kind of slightly hysterical laughter that comes from realizing that a problem you thought was unsolvable might have just been solved by a guy with a welding torch and some scrap steel. Word spread fast. By the next morning, officers from the 102nd Cavalry Reconnaissance Squadron were examining the modified Sherman. By the afternoon, a colonel from the 2nd Armored Division had arrived to see a demonstration. Cullin, suddenly the center of attention, ran the test again. The colonel watched the Sherman cut through 3 hedgerows in succession, the tank moving at a steady pace without slowing, without exposing itself, without the drama and danger that had characterized every hedgerow crossing up to that point. The colonel asked how quickly the cutters could be manufactured. Cullin estimated that a decent welder could fabricate one in about 2 hours, maybe less if you had the steel precut. How many hedgehogs were sitting on the beaches? Thousands, someone said. Enough to equip every Sherman in the First Army if we wanted to. The colonel left to make a phone call. Within 2 days, the modified Sherman and Cullin himself were ordered to demonstrate the device for Lieutenant General Omar Bradley, commander of the 1st U.S. Army Group. Bradley, a mild-mannered but intensely competent officer, had been wrestling with the Bocage problem for weeks. He had read reports, consulted with engineers, approved experiments. Nothing had worked well enough to change the operational picture. He watched Cullin's demonstration in silence. The Sherman, now dubbed a Rhino after the appearance of its horns, cut through 5 hedgerows without difficulty. Bradley asked technical questions: how much steel was required, how long the fabrication took, whether the cutters would interfere with the tank's main gun or reduce its speed. Cullin and the tankers answered as best they could. The cutters added some weight, but not enough to significantly affect performance. The welds needed to be strong, battle stress would test them, but any competent welder could do the work. The steel from the hedgehogs was ideal, already the right gauge and hardness. Bradley made his decision on the spot. Every available hedgehog on the beaches was to be cut up and transported to ordnance depots. Welding teams were to be organized in every armored division and tank battalion. Every Sherman in the First Army was to be fitted with Rhino cutters as soon as possible. The work was to be done quietly. The Germans were not to know about this capability until it was used in force. The operation that followed was a masterpiece of improvised logistics. Ordnance companies sent teams to the beaches with cutting torches and trucks. The hedgehogs, thousands of them, were systematically disassembled into their component pieces. The steel was sorted, loaded, and shipped to forward depots where welding stations had been set up. Some stations were elaborate, using workshops and proper equipment. Others were just tarps strung between trees, a portable generator, and a couple of welders working in shifts. Tankers drove their Shermans through like an assembly line. In get welded out. 2 hours per tank if everything went smoothly, sometimes less. The scale of the effort was staggering. The First Army in late July 1944 included over 1,000 medium tanks, spread across multiple armored divisions and independent tank battalions, fitting all of them with Rhino cutters in a matter of weeks. While the Army continued combat operations, required coordination across dozens of units and the labor of hundreds of welders and ordnance personnel. But Bradley had given the order, and the Army made it happen. By the end of July, nearly 60% of the Shermans in the First Army had been modified. By the time Operation Cobra launched on July 25th, the percentage was closer to 75. Operation Cobra was Bradley's answer to the Bocage stalemate, a massive concentrated assault designed to break through the German lines west of St. Lo and open the way for a breakout into Brittany and beyond. The plan called for an unprecedented aerial bombardment to shatter the German defenses, followed by a ground assault spearheaded by armored divisions driving south and then wheeling west to exploit the gap. It was a gamble, the kind of operation that could either end the war in France or result in a catastrophic defeat if the Germans managed to contain it. The bombardment began on the morning of July 25th after a one-day weather delay. Over 1,500 heavy bombers from the U.S. 8th Air Force, along with hundreds of medium bombers and fighter bombers, dropped nearly 4,000 tons of high-explosive and fragmentation bombs on a rectangular area roughly 5 miles wide and 1 mile deep. The earth convulsed. Entire hedgerows were obliterated, craters 50 feet across appeared where fields had been, and German positions were buried under avalanches of dirt and debris. The noise was audible 50 miles away. Soldiers on the ground, even those on the Allied side, were stunned by the sheer violence of it. But carpet bombing, for all its destructive power, was imprecise. Some German units survived in deep bunkers or simply because the bombs fell in the wrong places. The hedgerows, even damaged, still existed as obstacles in many areas. And the Germans, veterans of the Eastern Front, were skilled at rapid reorganization after bombardment. By the time American infantry began advancing in the early afternoon, German machine guns and mortars were already firing from positions everyone had assumed would be annihilated. The real test came when the armor moved forward. The 2nd and 3rd Armored Divisions, reinforced by independent tank battalions, began their assault in the late afternoon of July 25th and into July 26th. Their objective was to push through the German defensive line, exploit any gaps, and drive south toward the town of Coutances, unhinging the entire German position in the Cotentin Peninsula. The tankers knew that even with the bombardment, they would face hedgerows. What they did not fully know yet was whether Cullin's cutters would work under combat conditions, with enemy fire, with damaged terrain, with the chaos and unpredictability of battle. The first Rhino tanks hit the hedgerows south of the bombing zone and simply drove through them. The German defenders, positioned to ambush tanks climbing over berms, found themselves facing Shermans that appeared from unexpected directions, cutting through hedgerows that were supposed to be impassable at ground level, emerging with their guns already level and firing. The carefully prepared defensive positions, dug into the bases of hedgerows and oriented toward the expected approach routes, became death traps. Shermans appeared behind German positions, flanking them, overrunning them before the defenders could relocate. The psychological effect was immediate and devastating. The Bocage, which had been the Germans' greatest ally, suddenly worked against them. They could not see where the American tanks would come from. The sound of Sherman engines no longer meant a predictable threat climbing slowly over a berm. It meant armor that could appear anywhere, cutting new routes through the landscape. German infantry, already shaken by the bombardment, began to fall back or surrender. Anti-tank teams found themselves bypassed or unable to get into position before the Rhinos were past them. The American advance, which had been measured in hundreds of yards per day for the previous month, suddenly accelerated. By the evening of July 26th, elements of the 2nd Armored Division had pushed over 4 miles south of St. Lo, a distance that would have taken a week in previous fighting. By July 27th, the German line was crumbling. By July 28th, American armor had reached Coutances, over 15 miles from the starting point, and the German 7th Army was in full retreat. The numbers tell part of the story, but only part. In the first week of Operation Cobra, American forces destroyed or captured over 400 German tanks and assault guns, killed or captured over 20,000 German soldiers, and advanced nearly 30 miles, all in terrain that had previously limited advances to a few hundred yards per day. American tank losses, which had been catastrophic in the early weeks of the Bocage fighting, dropped dramatically. Tanks equipped with Rhino cutters had a survival rate roughly twice that of unmodified Shermans in comparable operations. Crew casualties, the real measure of human cost, fell by a similar margin. The German commanders, trying to understand what had happened, wrote in their after-action reports of American tanks that could move through hedgerows as if they did not exist, and of defensive positions that had been bypassed or overrun before they could effectively engage. General Heinrich Eberbach, commanding Panzer Group West, noted bitterly that the Americans had solved the hedgerow problem through technical means, rendering weeks of careful German defensive preparation obsolete. But the impact of Cullin's invention went beyond Operation Cobra. The breakout from Normandy, which began in late July and continued through August, saw American and British forces sweep across France at a pace that matched the German blitzkrieg of 1940. Paris was liberated on August 25th. By early September, Allied forces had reached the German border. The war in the West, which had seemed mired in bloody stalemate in July, had transformed into a war of movement and pursuit. Historians would later debate the relative importance of various factors in this transformation: air superiority, logistics, German exhaustion, but few would dispute that the ability of American armor to operate effectively in the Bocage was a crucial enabling factor. And at the center of it all was a simple device. For pieces of scrap steel, welded to the front of a tank, designed by a truck driver from Tennessee who had never studied engineering, Curtis Cullin received the Legion of Merit for his invention, a decoration given for exceptionally meritorious conduct in the performance of outstanding services. The citation noted his ingenuity and initiative, and credited him with significantly contributing to the success of operations in France. He was promoted, his name mentioned in dispatches, his photograph taken for army publications. For a few weeks, he was something of a minor celebrity within the First Army. Then the war moved on, as wars do. The Bocage gave way to open country, then to the urban fighting in German cities, then to forests and river crossings. The Rhino cutters, so crucial in Normandy, became unnecessary as the terrain changed. Maintenance crews removed them to save weight and reduce wear on the tank's front suspension. By September, most Shermans were operating without the cutters, and by October, they had largely disappeared from frontline use. Cullin himself continued to serve. In November 1944, during operations near the German border, he was wounded. Shrapnel from a mortar round. Not serious enough to be life-threatening, but enough to warrant evacuation and eventual return to the United States. He recovered, received an honorable discharge, and went home to Tennessee. He did not speak much about the war, which was typical of his generation. He worked, married, raised a family, lived a quiet life. The Rhino cutter, the device that had helped break open the Western Front, became a footnote in military history, mentioned in specialist texts but largely forgotten by the public. Cullin himself was even less remembered, his name absent from most popular histories of World War II, his contribution unknown to the vast majority of people who benefited from it. Yet the impact of his work rippled forward through time in ways both direct and subtle. The concept of tank-mounted breaching devices became standard in military doctrine. Modern main battle tanks carry similar equipment: mine plows, bulldozer blades, explosive line charges, all of them descendants of the same principle Cullin demonstrated. That mobility in complex terrain requires specialized tools, and that those tools need to be organic to the tank itself, not dependent on engineers or external support. The M1 Abrams tanks that fought in Iraq carried mine plows that would have been instantly recognizable to Cullin as variations on his theme. The engineering vehicles that breach obstacles for NATO forces today use technology far more sophisticated than welded steel rails, but the doctrinal DNA traces back to the same insight, that breakthrough requires the ability to create your own routes, not to wait for someone else to prepare them. The human dimension is harder to quantify but no less real. How many tankers survived the war because Rhino cutters gave them a way through hedgerows without exposing their belly armor? How many infantry soldiers lived because armored support could keep pace with them instead of being channeled and destroyed? How many German soldiers, conversely, died or were captured because their defenses were rendered obsolete by a device they had no counter for? The numbers run into the thousands at minimum, and they compound. Those who survived went home, had children, built lives. The second-order effects, the families that existed because a soldier came home from Normandy instead of dying in a burning Sherman, extend across generations. Curtis Cullin died in 1963, at the age of 48, of a heart attack. His obituary in the local Tennessee newspaper made brief mention of his war service but did not describe the Rhino cutter or its impact. Few people outside his immediate family knew what he had done. There was no state funeral, no presidential recognition, no memorial. He was buried in a small cemetery outside Cranesville, his grave marked with a simple military headstone that gives his rank and dates of service, but nothing more. Yet in the summer of 1944, in a few square miles of Norman farmland turned into mechanized hell, Curtis Cullin changed the course of a war. Not through heroism in the traditional sense. He never fired his weapon at the enemy during the invention of the Rhino cutter, never led a charge, never held a position against overwhelming odds. He changed the war through something quieter but equally powerful. The ability to see a problem clearly, to imagine a solution, and to make that solution real with whatever materials were at hand. The Sherman tanks rolling through the hedgerows that July were crude, improvised, ugly. The welding was functional rather than beautiful. The concept was so simple that in retrospect it seems obvious. Why did no one think of it earlier? But that is the nature of breakthrough innovation. It looks obvious only after someone has done it. Before Cullin, hundreds of engineers and thousands of tankers had looked at the same problem and not seen the solution. The hedgehogs had been sitting on the beaches since D-Day, visible to everyone, and no one had thought to repurpose them. It took a specific kind of mind, practical and mechanical and unencumbered by formal doctrine, to make the connection. In the vast machinery of World War II, the millions of men under arms, the thousands of tanks and ships and aircraft, the industrial might of nations mobilized for total war, individual contributions can seem negligible. One soldier, one invention, one moment of insight. How much can it really matter? But the reality of war, perhaps the reality of history itself, is that these small moments accumulate into large outcomes. The sergeant who welds steel to a tank in July enables the general who orders the breakout in August. The tankers who survive because of that steel go on to cross the Rhine, to liberate concentration camps, to end a war. The chain of causation is never clean or simple, but it exists. Stand today on the beaches of Normandy, and you can still find, buried in the sand or rusting in the surf, fragments of Czech hedgehogs. The invasion they were meant to stop came anyway, overwhelming them through courage and blood and material superiority. But in a sense, the hedgehogs had the last word. Transformed from obstacles into tools, they helped break the very defenses their creators had thought unbreakable. There is something fitting in that, something that speaks to the fundamental unpredictability of war and the ways human ingenuity can turn an enemy's strengths into weaknesses. The fields of Normandy look peaceful now, the hedgerows still standing, the bocage returned to agriculture. Tourists walk the beaches, visit the cemeteries, photograph the monuments. Few of them know that the breakout they read about in history books, the spectacular Allied advance from Normandy to Paris, the liberation of France, the beginning of the end for Nazi Germany, was enabled in part by a truck driver who had an idea and the skill to make it real. Curtis Cullin's name is not on any monument. His face does not appear in documentary films. His story is absent from most textbooks. Yet in the summer of 1944, he saved thousands of lives and helped change the outcome of the largest war in human history. He did it not with grand strategy or overwhelming force, but with 4 pieces of scrap steel and the understanding that sometimes the most profound solutions are the simplest ones, if you can see them clearly enough. In the end, that might be the real lesson of the Rhino cutter. That history is shaped not only by generals and politicians, by grand designs and sweeping campaigns, but also by individuals whose names we never learn, whose contributions we never celebrate, who nevertheless alter the course of events in ways that ripple forward through time. The war would have been won eventually, even without Cullin's invention. The Allies had too much material superiority, too many advantages in resources and production. But it would have been won more slowly, at greater cost, with more names added to the casualty lists and more families receiving telegrams they dreaded to open. Somewhere in Tennessee, Curtis Cullin's descendants live their lives, most of them probably unaware of exactly what their grandfather or great-grandfather did in the summer of 1944. Somewhere in France, perhaps in Normandy itself, there are people alive today whose grandparents survived the war because American tanks could move through hedgerows without being destroyed. They do not know Cullin's name either, do not know the chain of causation that connects his welding torch to their existence. But the connection exists, invisible and undeniable, a thread in the vast web of history that we can trace if we look carefully enough. One man, one idea, one moment of insight that changed everything. That is the story of Curtis Cullin and the Rhino cutter, not a tale of glory or heroism in the conventional sense, but something perhaps more profound. A reminder that the fate of thousands can turn on the ingenuity of one, and that the greatest innovations often come not from experts or specialists but from people who simply refuse to accept that a problem is unsolvable. The hedgerows of Normandy still stand, ancient and enduring. But for a few crucial weeks in the summer of 1944, they were no match for scrap steel and human determination. If you found this story compelling, I'd love to hear your thoughts. Subscribe to the channel to explore more forgotten stories from World War II and beyond, the battles that changed history, the innovations that altered wars, the individuals whose names we should remember. Hit the like button if the story resonated with you, and drop a comment below. Do you think modern militaries still leave room for this kind of improvised innovation? Or has warfare become too complex and technical for individual ingenuity to matter? What other overlooked innovations from history should we examine? I read every comment, and your suggestions often shape future episodes. Thanks for listening, and I'll see you in the next one.